Oh, we're told to distillate the diameter. Okay, the next thing that we're told this line is equal to this line. So these two lines are going to be equal. Now, if these two lines are equal, the other thing that we're told which this one here is 35. And then they say calculate with reasons the size of R2. Now, where is R2? We can see R2. R2 is next to the one that we know. Okay? So what is going to be our R2? We say our R2, it's simple. If they say to us they want R2, we'll say A. First thing we're going to tell them with R1 is going to be 90 degrees. When they ask us why we're saying that, we're going to say its angles in half a circle. And then we tell them, okay, but now if that one R2 it means it's going to be 90 degrees because we have angles on a straight line. We are good with that one, okay? And then the next one, they said to us, go and tell us what is going to be S2. And then we said the way we are going to get S2 is to look at triangle TRS. Okay? So we have triangle TRS. Guys, if you're going to work with triangles, just name the triangle that you're going to work with so that we know exactly, especially talking about what. So we have number B, triangle TSR. If you go to TSR, this one you know is 90. Okay? Then if this is 90, then it means which you can get S2. How did we get our S2? We got our S2 by saying 180 minus 90 minus 35. Right? And then it gives us what? 55. And then the reason what we are using here is because we have sum of angles in the triangle. Are we still fine? So now that we know which this one here is 55 degrees, now that we know which this one here is 55 degrees, we want to get Q2. Now, how do we get this Q is going to be equal to 35? Now, what is the reason why we're saying Q2 is going to be equal to 35? The reason why we're saying is because we have QSR, which is congruent to triangle TSR. Are we together there? Now, we are looking for Q1. Now, let's go and find Q1. How would we find Q1? Now, this is how we find Q1. We know which we have SPQR, which is a cyclic quadrilateral. Look at this. We have this from here to here, to here, to here, which is a cyclic quadrilateral. Right? Now, this angle here is an exterior angle of a cyclic quadrilateral. It's an angle outside. Okay? Now, this is an interior angle of a cyclic quadrilateral. Do you see that? Okay? Now, this is an interior angle, this is an exterior angle of a cyclic quad. So in other words, it means that we can say Q1 is going to be equal to, in fact, we can say this, S2 is equal to Q1 plus Q2. The reason why we're saying S2 is equal to Q1 plus Q2 is because we have exterior angles of a cyclic quad. Does it make sense? This angle here, can you see this angle here? It's equal to this angle here. But now we know what is this one already. What is this angle here? 85. So what should we put here such that these two are going to be equal? This is going to be 20. So we'll come and say Q1 is going to be equal to 20. And then the reason that we're using here is opposite angles of a cyclic. No, it's not opposite angles. It's exterior angle of a cyclic quad. Sorry about that. So these two are going to be equal because we have exterior angle of a cyclic quad. Okay, we're left with the last one, P1 again. Now, what is going to be our P1? Here is P1. It's obvious, this one again. What is going to be P1? P1 is going to be equal to 20. How? Tell them why P1 is going to be equal to 20. So we have angles opposite equal sides. And then we are officially done.